When you think about diabetes, your mind probably jumps to blood sugar, right? Insulin, diets. But one of its most devastating complications is something much more hidden and way harder to treat: a diabetic foot ulcer. And look, these are just simple sores. They're these chronic, incredibly complex wounds that can spiral into infection, amputation, and, well, even worse. So to really understand what's going on, we have to look at the numbers.
And this number, this one is tough to hear, but it's so important. If you have a diabetic foot ulcer, your 5-year risk of death is 2.5 times higher than a person with diabetes who doesn't have one. To put that in perspective, that puts its mortality rate right up there with some of the most aggressive forms of cancer. It's an absolutely staggering statistic.
Which leads to the big question, right? Our bodies are amazing healing machines. We get cuts, scrapes, they heal up. It's what we do. So what on earth is happening in the diabetic foot that causes this fundamental, incredible process to just completely break down? To find the answer, we have to go right back to the beginning, to where the wound first starts.
To get it, you have to understand the environment that allows these ulcers to form in the first place. You see, they don't just pop up out of nowhere. No, they are the end result of a perfect storm. A storm created by two major underlying problems that diabetes causes in the body over years and years.
And it really boils down to this brutal 1-2 punch. First, you've got nerve damage, which is called neuropathy. And simply put, that means you can't even feel it when you get hurt. Then, on the other hand, you've got artery disease, or ischemia. And that means your body can't get the supplies it needs to the wound to actually heal it. You can't feel it, and you can't heal it.
Think about what a disaster this creates. The nerve damage, the neuropathy. It's like someone cut the wires to the fire alarm in your house. A little blister from a shoe that rubs the wrong way, a tiny cut from stepping on something, you would have no idea it's even there. At the exact same time, the artery disease means the roads are all blocked. The supply routes are cut off. So even if the alarm did go off, the fire department, all those crucial oxygen and nutrient and repair cells, can't get through the gridlock to the scene of the fire.
Okay, but that perfect storm is just how the wound forms. That leads us to the next and, honestly, the more critical question. Once the ulcer is there, why doesn't it heal? This is where things get really wild, because we're talking about a fundamental breakdown of the body's entire repair system.
Normally, in a healthy body, healing is this beautiful, elegant 4-act play, right? First, your body stops the bleeding. Then, it sends in special cells to clean up the mess and fight off any germs. After that, it starts rebuilding new tissue. And finally, it remodels and strengthens that tissue. It's this perfectly coordinated, beautiful dance.
But in a diabetic wound, that beautiful dance comes to a grinding, screeching halt. The whole process just gets stuck, frozen in place during one of its most critical phases.
Think of it like a construction project. In a diabetic wound, the body's cellular repair crew shows up to the site, all ready to go. But they get stuck on demolition. That's the inflammation phase, and they just keep tearing things down. They never get the memo to put away the sledgehammers and actually start rebuilding.
You can see here how this whole process just gets totally derailed. See, inflammation is supposed to be temporary, just the first step that kicks off the rebuilding and remodeling. But in these wounds, the body gets trapped in that first stage. And chronic inflammation, well, it actually starts causing more damage instead of fixing anything.
And this confusion runs through the entire cellular crew. Your macrophages, the guys who are supposed to clean up and then signal the rebuild, they just stay stuck in attack mode. The fibroblasts, who are supposed to build the scaffolding for new tissue, they never get the call to come to work. The endothelial cells, they fail to build the new blood vessels needed to supply the project. And the keratinocytes, the ones that are supposed to migrate across and close up the surface, they don't move. Every single key player is confused and failing at their job.
Okay, so this brings us another level deeper. If the entire construction crew is confused, you have to ask, who's in charge here? Who's giving them these terrible instructions? It turns out the problem isn't the cells themselves, it's the messages they're receiving.
So we have to figure out what's scrambling the communications network at the most basic level. The answer lies in the microscopic world of cellular signals.
This whole communication network is run by things called signaling pathways. The best way to think of them is like a series of microscopic radio frequencies. They carry super specific instructions to every cell, telling them exactly when to turn on, what to do, and, just as importantly, when to stop.
And here's the absolute crux of the problem.
the high-sugar, high-inflammation environment of diabetes acts like massive signal interference. It's just static, so the instructions being sent out to that repair crew get totally garbled. The cells are trying to listen, they want the instructions, but all they're hearing is noise.
And the result of all that static is exactly what we see happening in the wound. That inflammation signal, it's like a button that's jammed in the on position. It just keeps broadcasting. Meanwhile, the crucial rebuild signal, it never even gets through. And the create supply line signal, the one needed to build new blood vessels, it's so faint, so weak, it's basically ignored. The whole project is just paralyzed by bad communication.
So now we're at the deepest, most fundamental level of this whole problem. Because what if it isn't just signal interference? What if the diabetic environment has actually gone in and rewritten the body's core instruction manual?
This gets us into the fascinating world of epigenetics. Now, this isn't about changing your actual DNA sequence, your genes themselves. It's about changing how your body reads that DNA. Epigenetic changes are like little switches on your genes, telling them when to turn on and when to turn off. And what scientists are discovering is that the chronic high-sugar environment of diabetes can physically flip these switches, literally rewriting the instructions for healing at the genetic level. So if the body's DNA is the master blueprint for the construction project, epigenetic changes are like someone going through that blueprint and slapping sticky notes all over it, covering up the correct instructions, telling the crew to do the wrong thing, or just ignore a crucial step completely.
And these rewritten instructions, they're catastrophic for healing. They can cause those pro-inflammatory genes to get stuck permanently in the on position. They can flip the switch on crucial repair and growth genes, turning them permanently off. And over time, they can even make the cells deaf to any correct healing signals that might manage to get through all the noise. The very blueprint for repair has been corrupted.
Now, I know this all sounds incredibly bleak, but honestly, this is where the real hope is. Because by understanding the problem at this deep molecular level, from the broken fire alarm all the way down to the faulty genetic blueprints, scientists can finally start designing solutions that target the real root of the problem.
And this deep understanding is opening up a whole new frontier for treatment. We're now seeing really exciting research into drugs that could correct those scrambled signals, or using stem cells to deliver a fresh set of correct instructions right to the wound. And maybe the most exciting of all, therapies that could one day go in and actually erase those faulty epigenetic sticky notes, restoring the body's original healing blueprint.
Which leaves us with this final, critical question. For decades, we've been trying to treat these wounds just from the outside. But now that science can actually read the scrambled internal signals and see the corrupted genetic code, the real challenge, and the great hope, is whether we can finally learn how to send the right messages and help the body heal itself from within.